Welcome dear students. Today, at the request of some of the students, I am going to explain the graphical method of addition of two vectors first, and then I will explain the mathematical method of adding the two vectors. Suppose we have a vector A of definite magnitude and in the direction as shown, and another vector B of some definite magnitude and in the direction as shown. And let us first see the sum A plus B of the two vectors. So when we are adding B to A, means when we are calculating A plus B, then what we do, we'll take this vector without changing its magnitude and direction and attach its tail to the head of the vector A. Then this will represent the same vector B. Now these two vectors have been added. So what is the resultant vector? Resultant is this one, which is clear from the figure. How you understand it? Suppose a person takes a book from this point to this point, and the other person takes the book from this point to this point, then the net displacement of the book will be certainly this one, which we can see naturally it is happening. So this third side of this triangle, this line segment, is telling the magnitude and the direction of the sum of these two vectors, and will be written as R equal to A plus B. You can see that if the two vectors A and B are not parallel, then the magnitude of the resultant vector R will not be equal to the sum of the magnitudes of the two vectors A and B. It will actually be less than the sum of the magnitudes of the two vectors A and B. This fact you know from the beginning, from the properties of triangles, that the sum of two sides of a triangle is always greater than the third side. The same is holding good or true here too. Now suppose instead of getting A plus B, we have to get B plus A, then what will happen? Then we will keep the vector B as such, take vector A and attach its tail to the head of B without changing its direction and magnitude. Then this will be the case. And now the resultant will be obtained by connecting the tail of B with the head of A, and this segment, line segment, will give the resultant vector R equal to B plus A. From the graph you can see that these two vectors R and call it R1, they are equal. So what do we conclude? It means that the vector addition follows the law of commutation for addition. That is A plus B equal to B plus A. It means no matter which vector we take on which side becomes immaterial. A plus B or B plus A, we can take any vector first and then add the second to it. The resultant will be same always. The process of adding two vectors gives rise to a law naturally. That is called the law of addition of law of triangle for the addition of vectors. What happens in this law? What do we actually state? That if two vectors are represented by two sides of a triangle, then the third side of the triangle, but in opposite sense, represents their sum. In this triangle, LM is the first side, MN is the second side. LM represents vector A, MN represents vector B. So NL, the third side, but in opposite sense, that is LN, will represent the sum of the two vectors A and B. This is what is called law of triangle for the addition of the vectors. Now we will try to understand how a vector is subtracted from the other vector. In this diagram, we have two vectors A and B. If we have to add A to B, then what we do actually, we will take one vector and connect its tail to the head of the second vector, and then connect the tail of the first vector to the head of the second vector, and we get the sum. Now suppose we have to find out A minus B graphically. Then what is to be done? For that we must understand that if we change the direction of this vector, we reverse the direction of the vector B without changing its magnitude, then this vector is minus B. Now our task has become easier. Take minus B to the head of A this way. What we have done now, I have connected the tail of minus B to the head of vector A. So this line segment will tell the difference A minus B, which is equal to actually A plus minus B is equal to A minus B. So basically subtraction is a process similar to the addition of the vectors. But what we are doing here is only we are just reversing the direction of the second vector which is to be subtracted, and then take this vector minus B, attach its tail to the head of A. This will be A plus minus B, which is actually A minus B. This is how we get the difference A minus B. On the other hand, if we have to find B minus A, then what will we do? We will reverse the direction of A without changing its magnitude, and then A will become, on reversing the direction, minus A. This vector will be now taken here, and its tail will be connected to the head of B, and then the tail of B will be connected to the head of minus A. This line segment will give us the difference B minus A, and it will be directed from this side to this side. And you can see that B minus A, which is this one, is in magnitude equal to A minus B, but opposite in direction. So what we can obtain from the graph is that A minus B is equal to negative of B minus A. It means the commutative law of addition does not hold true for subtraction of the vectors.